But also look at special kind of factoring that we're going to talk about right now. And start out with the difference of perfect squares. The difference of perfect squares. A while back, we talked about a problem like this. We had x plus 5 times x minus 5. We multiplied this out vertically, and we saw something happen, that there would be no middle term. And I said to you, since when the same values but different signs, the middle are different, plus and a minus, there's no middle term, so we could just say that this is going to be x squared minus 25. Okay? And we did those before. Now let's look at the other way. Now we're going to give us a perfect square. We're going to look at the difference of perfect squares. So if I say, example 1, we say y squared minus 36. And again, a little review. It says, well, how do I want to factor this. And you say to yourself, does it have any GCF? No. It's a binomial factoring, but how? How are we going to have a binomial factoring? We're going to recognize that y squared is perfect and 36 is perfect. Those are two perfect squares. So this is the difference of perfect squares, y plus 6 and y minus 6. Okay, that's what we call the difference of perfect squares. First, so we want to ask ourselves, is there GCF? No. No GCF. Are they the difference of perfect squares? Let's see. Are these numbers perfect? Let's look at something else. We have x to the 4th. Perfect squares because it's x2, x2. And is 100 perfect? Yes, it is. It's 10 and 10, negative. And signs are going to be different, positive 10 and negative 10. So the difference of perfect squares, and this turns out to be the easiest of all factoring. Your job is to recognize, okay, those are two perfect squares. That's how I'm going to factor them. So let's make them a little more difficult. So we have 3. I have 81y squared minus 169 p squared. Okay? So we look at these numbers. 81 and 169 have nothing in common besides 1. What are we going to do here? So the p and the y have nothing in common. Then you ask yourself, then you go down the list. Okay, if there's no GCF, are they perfect? 81 is perfect. That's 9 and 9. 169 is 13 and 13. Those are perfect. Y squared, perfect, perfect. So this is going to be the difference of perfect squares. So we break that down. That's 9y minus 13p and 9y plus 13p. So you can see why this is a favorite of most students, because it is the most straightforward way to factor. So again, now we say GCF, and then before we go into binomial factoring, we say GCF and we say the difference of perfect squares. And we'll keep adding to this list, and then last is the binomials. Okay? So we got the GCF, difference of perfect squares, we can now add to our repertoire, and then binomials, we started last lesson, and we're going to continue with this lesson, because you know they're going to get harder. The last lesson, we dealt with the signs being the same, right? We dealt with the signs being the same, and now we see our first taste of different signs. These are both plus, minus, canceling out our middle term, giving us the negative at the end. Let's look at some with different signs now. Okay? And let's see, we have y squared plus 5y minus 6. 5 squared, y squared, and we want to factor this. We're going to factor this. And now we're going to do the same thing we did before. We're going to set up our factors. We know that y squared is y and y. Now, and we're going to say 6. We're going to do the same thing. List the factors of 6. We're going to say 6 and 1, 3 and 2, and that's it. So just those two factors. But now, this tells us, this is actually telling you, subtract. Signs are different. Because again, remember, when you multiply, how do you get a negative? the signs must be different. When we multiply and get a positive, the signs are the same. Either they're both negative, negative, or positive, positive. When we multiply and get different signs, that means one's a plus, one's a minus, and we can put that in, plus, minus. Now we got to figure out which one of these factors will work, and not only that, we got to figure out which one is the sign. So when we subtract, so this is saying that we're going to subtract